Hello guys, so welcome back to my YouTube channel. So today we are going to discuss another important most asked Google interview question. So the question is the earliest moment when everyone became friends. So the question states that there are n people in a social group labeled from 0 to n minus 1. You are given an array logs where log I is equals to timestamp I, xi, yi indicates that xi and yi will be friends at the time timestamp I. Friendship is asymmetric. That means if A is friends with B, then B is friends with A. Also, person A is acquainted with person B if A is friends with B or A is friend of someone acquainted with B. Return the earliest time for which every person become acquainted with every other person. If no such earliest time exists, then return minus one. So what we are given is like we are given the timestamp at which the two people become friends, and if one is friend of two, then two is automatically the friend of one. It works like Facebook friend. And we have to like make all the n friends connected here. So basically like if we are given n friends, then we have to return a timestamp at which all the n friends uh, became friends to each other, means all the n nodes become connected and become only one component. So initial the example which is given to us is this. So how we'll solve this question? So here we will have to form a graph in which we will have to take n nodes, and we just initially all those nodes will be disconnected, and then we have to connect those nodes, and so that all the nodes become connected and they form only one component. So that is the thing which we have to do. We will consider this example, and like let's copy this example and we will paste it here. Let me paste. Mm, yeah, so we have pasted it, and so we will consider this example and we will see how this answer is coming, and we will also discuss the solution here. So let me take out the pen and then we can start discussing. Let me clean it up. So yeah, so initially what we'll do is we will sort this initial vector which we'll get. So here we'll be implementing one algorithm, like we need to form a minimum spanning tree. You can search it on Google. So yeah, so what we'll do here is like we will sort this initial vector, and so this will be sorted in the increasing order of timestamp, and hence first we'll analyze the first timestamp. So at first timestamp initially we can see that all the nodes are disconnected. You can easily see that all the nodes are disconnected and initial connections are zero. So what we need to do is we need to form total n minus 1 connections, because if n minus 1 connections are formed, then like our graph will become connected. So there will be only one component. So initially connections are zero, and we'll like initially we'll assign the parent, like we will use union find. So in this what we'll do is like we will assign the parent of 0 as 0, 1 as 1, 2 as 2, 3 is 3, 4 is 4, and 5 is 5. So when the first timestamp comes, so in that case when the first timestamp comes, so here 0 and 1 will become connected, so we will connect 0 and 1, and here the first parent will be 0 now. So connections will increase to 1, then 3 and 4 will come. So we'll connect 3 and 4, and 3's parent will remain 3 and 4 parent will become 3. So here connections have become 2 now. So we need to go up to 5. Connection should be 5 because initial n is 6. So it is not scrolling down right now. So let me just exit it out. So up to here we have understood connections 2, and so yeah, connections 2. So next after this we'll get 2 3 also. So 2 3 are again not connected, So we will connect them. So what we'll do is so 2 and 3 here will become connected, and 2's parent will also be 3. Then after that this comes, and 1 and 5. So for connecting 1 and 5, we'll check what is the parent of 0. Sorry, what is the parent of 1? So 1's parent is 0, and fifth parent is initially it is 5 only. So we'll set that fifth parent will be now 0. So fifth parent will be now 0. So these are kind of connected, and these are also connected. So connections is equals to 4. So till now we are left with just two components. So we need to reduce it to one component. So yeah, let me exit it out again. And now what will happen is now this timestamp will come, and here 2 and 4 will we will have to connect, but we can see that they are already connected because they are the same parent. So connections still will remain 4, and nothing will happen here. So in the next step 0 and 3 come, and we'll connect 0 and 3, and 3's parent will become 0. So here connections have become 5, and here as connections is equal to n minus 1. So this timestamp is our answer. So 20190301 is our answer. So we can see here that 20190301 is our answer. So this is the algorithm which we'll be using. Now let's go to the code part of it. So initially what we are doing is we are sorting. So this is an algorithm which is known as, I think, topological sort. So initially we'll sort our initial vector, and then we'll define one parent array, and we'll also define one size array which will contain, like, for each parent what is the size of its connected component. Initially we will initialize all the parents as the parents of itself. So 0's parent will be 0, 1's parent will be 1, as we had done here. So here 0's parent was 0, 1's parent was 1. So we'll initialize this like this, and initially our connections will be 0. So here our connections were 0. So connections will be 0 initially, and then we will go through each of the component which we are getting. So timestamp will store, like, 0th index is the timestamp, node 1 is the first index, and node 2 is the second index. Then we'll check like we will find out the parent of first node. So here we are finding out calculate parent of node 1, and here we will calculate parent of node 2. And if node 1 and node 2 parents are not equal, that means that uh, like our node 1 and node 2 are not connected. So in that case only we will increase our connections, because you can see that in one of the example, so in this example 2 and 4 were already connected, so its parent will be 3 only. So we don't need to increase connections in this case. So if node 1 and node 2 are not equal, so we'll increase the connections, and then we'll check like if the node 1 size is greater, then node 2's parent will become node 1. Otherwise if node 2 size is greater, then node 1's parent will become node 2. And here we'll also check if connections is equals to n minus 1, then we'll return our timestamp. And if nothing, like if we have exhausted all of our elements in our vector and still we haven't returned anything, then it is mentioned in the question that if there is no such earliest time, then return -1. So that is why we are returning -1 at the end. So yeah, I think in this way we can uh, calculate our answer. So time complexity, if we see here, it will be n log n, here it will be n, and here like we are iterating n items, and here I think here like the time complexity is usually a constant, like it is O4 alpha. So you can check it out on Google, like why it is 4 alpha, but like it is constant here. So here the time complexity will be On. So total time complexity will become On log n, because we are sorting also. So yeah, like we can check what is the value of n which is given to us. So n is 100. So sorry, log's length is given as 10 to the power 4. So 10 to the power 4 for n is equals to 10 to the power 4, n log n will work. So let's run this code now. So it is running. So yeah, it is working. And let me submit it as well. So yeah, it has got accepted. So yeah, this is the solution. So I will attach this solution in the comments, and I will also add this problem link and problem description in the description of the video. So I think you have understood the explanation. So yeah, stay tuned for more such important data structure and algorithm questions. Thanks and have a good day.